dividing monomials, and today I want to talk about factoring. Factoring, we started in lesson 5.1 by factoring integers. Factoring means, when we use that as a verb, a present participle, it means find the factors, right? So when we factored a number, for example, to go back to the beginning, when we said factor 12, factor it using it as a verb, right? We could say, well, it's 1 and 12, 2 and 6, 3 and 4, right? So that's just a basic review there of the factoring we did in 5.1. Notice that what we're doing for this is we are listing them as pairs of factors. We're always talking about two things that multiply. So what we're going to do today to do this with monomials is kind of a continuation of what we were doing yesterday. So if I were to say, let me go back to the 12 first. If I were to divide 12, let's say by 4, of course we get 3, right? So notice what happens here, and I'm using this 12 because I know that everybody understands what I'm talking about with a plain old number like 12. If the number I divide by and the answer that... Okay, so continuing, I will try to paste these together. If I take a number or any monomial and I divide it by something that it divides by, what do you notice about the divisor and the answer when we compare it to the factors list? Luke, what do you notice?
If you multiply them, you'll get the numerator.
Okay, that if we multiplied these, we'd get the factor, the number we started with, the numerator, right? Or another way to describe it, Vincent? Okay, that these are the pairs of factors. If we divide by something and it is divisible, 12 is divisible by 4, if we divide it, that divisor, and the answer are actually pairs of factors. If the opposite of division is multiplication, we could take those and multiply them. So I'm highlighting that because what we're going to be doing today is kind of extending the idea from yesterday. I'll give you a simple example like we were just doing. If I said a squared b divided by a, guess what? Here's one of my factors. The answer that we get when we do it is going to be the other factor. Just like you can see in the 12 that the 4 and the 3 are factors of 12. If I divide out an a, what's left is the second factor. What would be left here? Well, a squared divided by a, I could cancel out 1 and 1. That leaves an a in my numerator. The b, I can't simplify at all because there's no b's in the denominator. So the divisor and the answer are the two factors. Yesterday we did this work. I just didn't explain it as these being factors. So now we're just going to take a second step forward by recognizing that these are factors. Now, here's what your problems are going to look like today. Instead of showing the division, what you're going to see, and I'm going to try to pick one here that's simpler to start, let me find it here, is you will see a monomial like 18c to the power of 9. You will be given one factor. Remember that when we multiply, right, if we have multiple or bigger monomials here, the parentheses just show that I'm multiplying these two. And now what you're going to have to do today is to find the second factor. So here's one way to do it. One way you could do it, to follow up on yesterday's lesson, is you could say, well, if I divide by this first factor, my answer is that second factor. So if you want to, you can stack them like this to make it look like a fraction, and then we'll simplify it just like yesterday's lesson, and the answer becomes our second factor. So the difference here is that they're showing it over here instead of as a denominator. So we'll do this first one showing it like this, and then the second one I'll show you how you could even skip this step. 18 and 6 both divide by 6. C to the 9th divided by c to the 4th. When we divide the same base, we subtract. Or you could think I can cancel 4 from the denominator and 4 from the numerator, and that would leave 5. What I have is 3 c to the 5th over 1, and I'm not even going to include the over 1. There's my second factor. How do you know if you did it right? Well, you could multiply these. 6 times 3, 18, c to the 4th times c to the 5th. When I multiply the same base, I add the exponents. So this missing factor we found. Not too hard, hopefully. Make sense? Kind of. Let's do one more. Let's make it a little harder. Let's say this time our monomial is 48 x cubed y squared z to the 4th. And the first factor we're given is 3x y squared z. And we are going to find the second factor. Now, again, if you want to, I'm just going to turn the light on here so it's going to brighten up for a second. Let's see if that helps. If you want, I'm going to write this. You don't have to write this if you don't want to. I'll show you another way to do it without rewriting it. If you want to take that first factor and make it the denominator and do it that way, then again, your answer becomes your second factor. The other way you can do it, and many of you will be able to think this way. If this is confusing though, follow this method. Otherwise, some of you are going to be able to see the answer and visualize it by going, okay, if I divided a 3, or visualize 3 times what would make 48? 16. Okay, 3 times 16, there's my 48. Or if you did 48 and 3, you'd get 16. Okay, I have 1x and I need to get to x cubed. Oh, well, it must be an x squared. Right? If we were doing it down here, we'd go, oh, cancel 1 and cancel 1, and that would leave x squared. If you can visualize it side by side, you don't have to write it as a fraction. But if it's hard to do this, write it as a fraction. Y squared, oh, there's a y squared already. So how many y's are going to be in my new factor that I'm showing in green? Pammy? None of them. I don't write it at all. Z to the 4th, and I already have 1 z. Well, I must have 3 more coming from here. Now again, to show you how that would work when we divide, y squared and y squared, I can get rid of 2 and 2, they're gone, there's no more y's. Z to the 4th divided by z, I can get rid of 1, and 1 from here leaves z cubed. So if you do it this way, you should get the same answer. If you can do it just by looking to see, well, what would I multiply this by to get it back to my original monomial, then you can just fill in that second factor. Questions? Nope. Okay. So